Okay, this is classwork video 316. I'm going to have you look at and copy your work, check your work, and then write down the 5 secret words that I'll say randomly. So again, this concept here of solving variables on both sides equations and sometimes weird things happening, and then starting to recognize what parts that you have. So again, we're looking at one solution, no solution, infinite many, being able to solve variables on both sides equations, doing step by step, and then being able to recognize that no solution ones always have the same number in front of x, but a different y-intercept. One solution always has different numbers in front of x. As soon as you see that, instant one solution. And then, of course, the easier one, when everything's the same, that's your typical many solution. But again, knowing all the algebra steps and knowing the kind of ways that the answers that you get and what those tell you too. So here we go. First problem I'd like you to write down or check are these right here. Green. So again, looking at these, I need you to eventually just be able to tell me instantly one solution, no solution, many solution, just by looking at my parts. If I see that my numbers in front of x are different, as soon as I see that, that's a one solution, and then I need to be able to find that solution. As soon as you see things in front of that x number, always look at that x. The numbers in front of x are the same, but the numbers next to them different. That's parallel situation. That's a no solution, no solution. And then, of course, the last one, when everything's the same, got that same number in front of x, got that same exact y-intercept number. Those are overlapping lines or infinite solutions. One solution, always these lines that are intersecting, and we'll start to be looking at that right there. Turtle. So again, I also need you to be able to show the work on these. So here we go. Check your work against mine, step by step. If I take away this 6 on both sides and bring that 8x down and that negative 2x down, this is going to give me 30. Stay on that side, add 2x, add 2x. Those will cancel away. I'm doing adding because that's the opposite of that minus 2x, and that gives me 10x. And then right there, the last step, go back to your left side and divide. So there is the only solution in this universe to that problem right there. X equals 3, one solution. There's only one. There's no other number I could plug in for x and have this equation work. Only 3 will work right there. All right, and no solution one. When you start solving this, taking away 3, take away 3. That will give you 7x. 7x plus 7. Stay on that side. Get rid of the 7x by doing the opposite. And then that gives you that weird look of two numbers that aren't equal. Those numbers aren't equal. That's not a true statement. That's your typical no solution look. There is no number in this whole universe I could plug in here and times it by 7, add 3, and then take that same number, times it by 7, and then add 10. There's no way that there's an answer to that equation right there. And then, of course, the many solution. If you're solving this, taking away 3, that gives me 4x. Bring down that equal, bring down that 4x. This gives me 0 technically. Take away this 4x right here. And that gives you that weird statement when these cancel away too of 0 equals 0. That is true. That's true statement. So that's your infinite look. Infinite solutions. That means any number in the entire universe I could plug in here because I'm timesing it by 4 and then adding that answer by 3, and then taking that same number, timesing it by 4 and adding that same exact 3. Every number will work. Any number will make that solution, make that work. So again, know those look. Blue. All right, for this set right here, again, I want you to be able to give me those answers without having to do much of the math. So again, here we go. As soon as I see these are the same, but the y-intercept numbers are different, that's your no solution look. Write that on your paper. If I'm just asking for one solution, no solution, many, you don't really need to show work. You can just look at the parts. For this one, as soon as I see these numbers in front of x are different, that's a one solution look always. If I look at the numbers in front of x and they're the same, but these numbers are the same too, that's your infinite solution look. And then of course over here, looking at what I got, positive 3. This is negative 1x right there. Those are different numbers. That's your no solution. I'm sorry, that's your one solution. As soon as I see those numbers in front of x are different, one solution. This guy right here has same x numbers, same y-intercept numbers. That's infinite solution. And then of course your last one, I have numbers in front of x that are the same, but my y-intercept numbers are different. That's your typical no solution look. Shark. All right, last set here. They will do that, but have it in disguise. They're going to try to disguise it. They're going to try to fake you out and think, oh, here's 5 and here's 7. That's a one solution look, but they might have fooled you. They need you to be able to look a little carefully, because on this one, if I combine my like terms, that ends up being 7x plus 3, not just 5x. And then now when I'm looking at that, I have the same number in front of x, but a different y-intercept number. That's my no solution. It looked like a one solution almost, but nope, it's a no solution because those numbers are the same and the y-intercept's different. All right, this one again too, it looks like I got the same number in front of x, a different y-intercept number. Some people will be all, oh, that's a no solution, but be careful. It's kind of in disguise. If I distribute this, because you got to know how to distribute, that gives you 6x plus 12, and then another 6x plus 12. So you can see that now has everything the same. That's a infinite solution. Any number will work. And then of course this guy right here, what looks like at first, I'm looking at, ooh, here's 5, here's 5. That's going to be either no solution or infinite. But be careful. If you look on this one, it's tricky because it has you distribute and then combine like terms right there. So here I go. If I distribute, that gives me 5x plus 10. Bring down that minus 2x. And then right there, when I combine these two right here, that gives me that 3x look, which instantly is a one solution, because these numbers in front of x are different. That's your typical one solution look. So again, they will kind of disguise some of these, especially once you start getting good at knowing your looks and knowing what numbers in front of x and what y-intercept numbers. Good job. Thanks for listening. Reef.